Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. Let's look at evaluating the indefinite integral of 1 over x dx. At first glance, we might think we can use the power rule to do this, but let's see why this isn't possible. So let's write this integral as the integral of x to the power of minus 1 dx. Applying the power rule to integrate this, we add 1 to the exponent and divide by the exponent plus 1. So we get x to the power of 0 divided by 0. And as we can see, this is indeterminate as we have a divide by 0. So let's try a substitution method to evaluate this. So let's allow u equal to the natural log of x. Now we know from this video that if we differentiate u with respect to x, we get 1 over x. And this video will prove why, so it's definitely worth a watch. It therefore follows that du is equal to 1 over x dx. So now if we make our substitution where 1 over x dx is equal to du, we have the integral of du. And if we use the power rule to evaluate this, it evaluates to u. So now substituting back in for u, we get the integral of 1 over x is equal to the natural log of x plus a constant of integration c. While this is close to the solution, it's still not quite the full story. Let's see why by looking at the graphs of the natural log of x and 1 over x. So shown here is the graph of 1 over x, and here we have the graph of the natural log of x. For 1 over x, its domain is for all values of x except for x equals 0. So the function will take all values of x except x equals 0, as this will give us a division by 0. And for the natural log of x, its domain is defined for all values of x greater than 0. The domains of each of the functions are different, so this is why the natural log of x cannot be the antiderivative of 1 over x. So to counter this and make the domains the same, we use the natural log of the absolute value of x. This then converts negative values of x to be positive before applying the natural log function. This is the graph of the natural log of the absolute value of x. As we can see, it takes positive and negative values, but not x equals 0. So its domain is now the same as that of 1 divided by x. So the integral of 1 over x dx is equal to the natural log of the absolute value of x plus a constant of integration c.